Question 1. In light of recent developments in system efficiency analysis, a technician named Alexis is evaluating an air conditioning system during peak load conditions. The indoor air temperature is 75 degrees with 50% relative humidity, while the outdoor temperature is 95 degrees. Alexis notices that despite proper charge and airflow, the indoor coil is sweating excessively and return air feels clammy. Psychrometric analysis shows that the latent removal is inefficient even though sensible cooling is adequate. Which thermodynamic principle is most likely being compromised, resulting in the reduced latent capacity? A. The first law of thermodynamics. Energy cannot be created or destroyed. B. The relationship between specific volume and pressure in superheated vapor. C. The sensible heat ratio SHR exceeding design parameters. D. The latent heat of fusion in the phase change of the refrigerant. Answer. Correct answer. C. Explanation. Latent capacity suffers when the sensible heat ratio SHR is too high, meaning the system is favoring sensible over latent heat removal. This results in poor moisture control. The SHR is critical design parameter influenced by coil temperature and airflow. Cf. ASHRAE Handbook. Fundamentals, Chapter 1. In this case, airflow may be too high or coil temperature too warm, reducing dehumidification. Option A is general law, not specifically relevant. Option B is unrelated to humidity control. Option D refers to solid-liquid changes, not vapor compression processes. Question 2. To determine whether a system has been correctly charged using the subcooling method, technician Brian is working on a unit that uses R400 TINA. The manufacturer specifies a target subcooling of 10 degrees. His gauges show liquid line pressure of 300 sig and the liquid line temperature is measured at 88 degrees. Based on the PT chart for R400 TINA, the saturation temperature corresponding to 300 is approximately 95 degrees. What should Brian do next? A. Add more refrigerant to increase the subcooling. B. Remove refrigerant to decrease the subcooling. C. Do nothing if the system is correctly charged. D. Switch to the superheat method for accuracy. Answer. Correct answer. A. Explanation. Subcooling equals saturation temp. Liquid line temp equals 95 degrees. 88 degrees equals 7 degrees. Since the target is 10 degrees, subcooling is too low, indicating undercharge. More refrigerant is needed per ARI guideline and an RSA's service procedures manual. Option B would worsen the charge. Option C ignores the deviation from target. Option D is incorrect because subcooling is the proper method for TSV systems. Question 3. When evaluating the merits of vacuum pump performance, technician Nina observes that after pulling a vacuum for 30 minutes on a newly installed residential split system, the micron gauge stalls at 1500 microns and fails to drop further. The ambient temperature is 8 degrees. Which of the following is the most appropriate next step? A. Add refrigerant to help push out non-condensables. B. Increase pump oil temperature to improve flow. C. Check for system leaks or moisture contamination. D. Proceed with charging. A vacuum level is acceptable. Answer. Correct answer. C. Explanation. A vacuum should reach 500 microns or less for moisture removal per epoch. Section 608 in the CAS Standard 6. Stalling at 1500 microns indicates a leak or moisture presence. Option A introduces contaminants. Option B is not industry standard. Option D violates best practices and may result in system failure. Question 4. The predominant theory suggests that when balancing airflow in a variable speed air handler, technician Darnell measures a total external static pressure test of 0.9 WC, which exceeds the manufacturer's rated maximum of 0.5 WC. The airflow is significantly below the design 400 cm/ton. What is the most likely cause of this high static pressure? A. Oversized blower motor causing system restriction. B. Undersized ductwork or restrictive filters. C. Improper refrigerant charge increasing head pressure. D. Low voltage supply to blower motor. Answer. Correct answer. B. Explanation. High test typically results from ductwork restrictions, clogged filters, or undersized return supply paths. C. Manual. D. CAM manufacturer air handler specs. These reduce airflow. Option A misunderstands motor size effect. Option C impacts refrigerant pressures, not static. Option D may cause motor issues but not increased pressure. Question 5. Based on the information obtained during a routine maintenance check, technician Alina suspects a refrigerant leak in a system using R134A. She uses an electronic leak detector and picks up signals near the evaporator coil. To confirm, she decides to apply another method. Which is the most appropriate confirmatory test? A. Adding R22 to increase leak detection accuracy. B. Spraying a soap solution to detect bubbling. C. Installing a new metering device for better performance. D. Recharging system to maximum capacity and monitoring. Answer. Correct answer. B. Explanation. Soap bubble solution is a widely accepted secondary method for confirming leaks after an electronic detector indicates a leak per EPA, section 608 and ASHRAE standard 147. Option A is illegal and unsafe. Option C is unrelated. Option D risks refrigerant loss and environmental violation. Question 6. From a practical standpoint, when diagnosing a scroll compressor that starts but trips on overload after 10 seconds, technician Lewis checks voltage and amperage. Voltage is within 5% of nominal, but amperage spikes above ORA, locked rotor amps. What should Lewis check next? A. Thermostat calibration. B. Shorted windings in the compressor. C. Undersized ductwork. D. TXV bulb location. Answer. Correct answer. B. Explanation. High amperage at startup suggests internal electrical failure like shorted compressor windings. Refer to NEC Article 440 and NATE Service Guidelines. Option A wouldn't cause overload. C and D relate to system performance but not motor protection trips. Question 7. Taking into account the location and thermal properties of a newly built home in Phoenix, as technician Savita must perform a residential cooling load calculation. The home has large west-facing windows with minimal shading and a vaulted ceiling. Which of the following factors should be given special emphasis when performing the manual J calculation? A. Heat gain from the evaporator coil. B. Occupant moisture, load from kitchens only. C. Solar heat gain through fenestrations. D. Static pressure from the duct system. Answer. Correct answer. C. Explanation. Manual J requires accounting for solar heat gain, especially in sun-intensive zones like Arizona. West-facing windows allow intense afternoon sun, affecting cooling load. Evaporator coils don't add heat. Kitchens and duct pressure affect performance, not sizing. Cf. A CAM Manual J 8th ed. Question 8. To illustrate this point, technician Marisol is interpreting a ladder diagram of a cooling-only split system. She notes that the contactor coil is not energizing despite a call for cooling from the thermostat. The diagram shows the Y terminal connected in series with a float switch, high-pressure switch, and 24V transformer. Where should Marisol begin diagnosis? A. Across the compressor terminals. B. Across the 24V transformer secondary. C. Across the contactor coil itself. D. At the flow switch terminals. Answer. Correct answer. D. Explanation. If the Y signal passes through safety devices in series, any open switch, e.g. float switch, due to condensate backup, will break the circuit. Testing across switch terminals will show if it's open. Compressor terminals and transformer are secondary checks. NEC 725 and System Control Logic Best Practices. Question 9. When presented with an R400 Tina system showing signs of overheating during charging, technician George forgets to wear eye protection while disconnecting the manifold hoses. The liquid line bursts under pressure and causes refrigerant spray near his face. What safety violation did George most likely commit? A. Not using gloves designed for high-pressure refrigerants. B. Not purging nitrogen prior to charging. C. Not wearing proper PPE such as safety goggles. D. Overcharging the system with incorrect refrigerant. Answer. Correct answer. C. Explanation. OSHA 29 CFR 1910.133 mandates eye protection when working with pressurized systems. Liquid refrigerant spray can cause cold burns and blindness. Gloves are important but not the key failure. Nitrogen purging and charging issues are irrelevant here. Question 10. The contemporary view of system evacuation emphasizes removing moisture and non-condensables before refrigerant charging. Technician Amani pulls a vacuum using a two-stage pump, then performs a rise test. After isolating the vacuum pump, the system pressure rises from 300 to 700 microns in 15 minutes. What does this suggest? A. System is dry and ready for charging. B. System has a minor refrigerant leak. C. System contains moisture or a leak. D. Micron gauge is malfunctioning. Answer. Correct answer. C. Explanation. A micron rise indicates moisture boiling off, or a leak, especially with a large jump in a short time. EPA manufacturer protocols recommend vacuum stability before charging. A clean, sealed system should stay below 500 microns. Gauge malfunction would be inconsistent, not gradually rising. CF. An ASHRAE Guideline 32016. Question 11. Contrary to popular belief, technician Marcus is working with a high-efficiency heat pump using R400 TINA and notices that the system struggles to maintain capacity during low ambient conditions. The system is equipped with a pressure-activated head pressure control valve. After ruling out airflow restrictions and charge issues, Marcus suspects the refrigerant's thermodynamic behavior is the root cause. What principle best explains the challenge in low ambient performance? A. R400 TINA has a low boiling point and high glide, limiting low temp performance. B. The refrigerant's high pressure and low density impact compressor suction pressure. C. The blend nature of R400 TINA causes fractionation during subcooling. D. R400 TINA operates at nearly azeotropic behavior, limiting low side pressure variability. Answer. Correct answer. B. Explanation. R400 TINA operates at higher pressures than other refrigerants, and during cold weather, low suction pressure can reduce the evaporator's heat absorption. Its low density can result in poor mass flow and low compressor suction pressure, challenging capacity. ASHRAE Handbook. Refrigeration. Option A confuses R400 TINA with high glide blends like R407. Option C is incorrect as R400 TINA is near azeotrope. Option D misapplies azeotrope behavior. Question 12. Through careful analysis of a short-cycling rooftop unit, technician Simone discovers that the system shuts off intermittently without tripping any fuses or breakers. Voltage readings remain consistent. However, she observes erratic operation of the contactor coil. What is the most likely electrical fault? A. A defective transformer producing insufficient current. B. A short-to-ground condition at the compressor terminal. C. A high-resistance wire connection at the thermostat. D. An intermittent open in the control circuit wiring. Answer. Correct answer. D. Explanation. An intermittent open in the 24th control circuit causes unpredictable contactor behavior without triggering safety devices. NEC Article 725. It may result from loose spade terminals, corroded connections, or vibration damage. Option A would affect all 24 loads. Option B would trip protection. Option C might cause thermostat failure but not erratic contactor response. Question 13. In the absence of other system failures, technician Hawaii is troubleshooting a cooling-only system with a fixed orifice metering device. The system shows low suction pressure and high superheat but correct subcooling. What condition is most likely present? A. TXV hunting due to bulb insulation loss. B. Overcharge causing high condenser back pressure. C. Restriction at the metering device inlet. D. Moisture freezing at the evaporator exit. Answer. Correct answer. C. Explanation. High superheat and low suction pressure with correct subcooling indicates refrigerant isn't feeding properly through the metering device, likely due to restriction at the orifice inlet, e.g. debris or solder. This matches RE 700 and Arceus fault diagnosis charts. TXV issues are irrelevant. Overcharge increases subcooling. Moisture freezes at the inlet, not the exit. Question 14. The core principles of preventive HVAC maintenance are exemplified during technician Rita's quarterly inspection of commercial split system. She measures airflow, checks filter status, inspects electrical components, and cleans the evaporator coil. What added step most directly contributes to sustaining system efficiency and extending compressor life? A. Verifying refrigerant charge using subcooling or superheat. B. Measuring system decibel level near the condenser. C. Brushing off oxidation on electrical connectors. D. Replacing the air handler's transformer every 6 months. Answer. Correct answer. A. Explanation. Improper refrigerant charge, too high or low, causes compressor overheating and poor energy efficiency per cat. Standard 4 and RE 210 140. Verifying charge during PM enhances performance and longevity. Option B is part of noise diagnostics. Option C is good practice but secondary. Option D is unnecessary and excessive. Question 15. From a historical standpoint, technician Omar is retrofitting ductwork in a 1950s home using a central AC system. The original sheet metal duct system shows airflow issues with several rooms under condition. Static pressure tests reveal 0.3 W.C. on the return and 0.7 W.C. on the supply side. What should Omar prioritize? A. Install a variable speed motor to overcome static pressure. B. Replace all supply registers with high-velocity models. C. Resize and reseal supply ducts to reduce resistance. D. Add inline booster fans to long return runs. Answer. Correct answer. C. Explanation. Supply static pressure is excessive, indicating undersized or poorly sealed ducts. Per CAM Manual D. Duct resizing and sealing improve static pressure and airflow. Variable speed motors, option A, cannot compensate indefinitely for undersized ducts. High-velocity registers don't solve static pressure. Booster fans, D, help returns, not supply side. Question 16. By evaluating a rooftop condenser unit during peak summer operation, technician Layla notes that the head pressure is 75 psi higher than expected. Ambient temperature is 95 degrees and the condenser coil is clean. Subcooling is within range, but compressor amps are elevated. What could be causing the increased head pressure? A. Refrigerant migration due to liquid line siphoning. B. Insufficient condenser airflow from fan motor issues. C. Undersized metering device restricting refrigerant flow. D. Oil logging in the evaporator limiting mass flow. Answer. Correct answer. B. Explanation. High head pressure with clean coils and correct subcooling often indicates condenser fan motor issues, reducing heat rejection. CF, ASHRAE fundamentals and OEA guidelines. This elevates compressor load. Migration happens when off. Restrictive metering devices impact evaporator, not head pressure. Oil logging usually affects superheat. Question 17. In terms of control logic, technician Amber is troubleshooting a programmable thermostat on a heat pump. The system fails to switch from heating to cooling even after reprogramming. The reversing valve is confirmed operational when manually powered. Which thermostat wiring fault is most likely? A. W and Y terminals shorted. B. Reversing valve control wire connected to op incorrectly. C. RC and RH terminals not jumpered. D. R terminal not providing 24 from transformer. Answer. Correct answer. B. Explanation. Improper configuration of reversing valve terminals prevents the valve from switching modes. Some systems energize reversing valve for heating, others for cooling. Setting must match system type. CF. NEC 725 Honeywell install guides. Option A would trip protection. C. Affects dual transformer systems. D. Would disable entire thermostat. Question 18. When analyzing a no airflow complaint, technician Harvey finds the blower motor overheated and tripped its internal protector. Resistance checks confirm normal windings. Upon restart, motor runs briefly then overheats again. Capacitor values are correct. What should Harvey suspect? A. Faulty ECM control board. B. Undersized supply duct velocity. C. High static pressure exceeding blower rating. D. Incorrect thermostat programming. Answer. Correct answer. C. Explanation. Excessive static pressure forces motors to work harder, overheating even with correct electrical values. C. CAM Manual. D. Motor data plates. ECMs adjust speed but still face torque limits. Options A and D relate to control signals. B. May cause noise but not necessarily motor failure. Question 19. To what extent does understanding a schematic help technician Wesley troubleshoot a condenser unit that will not start despite proper voltage at the disconnect? The schematic shows a contactor coil wired through a high-pressure switch in the time delay relay. Voltage is present at the coil terminals, but the contacts won't close. What should Wesley do next? A. Jump the low-pressure switch temporarily. B. Replace the contactor immediately. C. Bypass the time delay relay to test continuity. D. Confirm coil continuity and inspect for burnout. Answer. Correct answer, D. Explanation. Voltage across a non-operating coil suggests an open coil or burnout. Continuity testing confirms this per NEC 430 and OEM diagrams. Jumping safety devices is unsafe. Replacing the contactor without diagnosis is premature. Time delay failure wouldn't show voltage across coil. Question 20. The effectiveness of technician Lena's refrigerant recovery procedure is evaluated after she uses push-pull method to evacuate large system. She observes that recovery rate drops sharply after the initial 70% is recovered. What is the correct procedure to follow at this point? A. Switch to the liquid port of the recovery tank to increase flow. B. Add nitrogen to pressurize the system and force out vapor. C. Transition to standard vapor recovery using the suction side. D. Use second recovery machine in parallel. Answer. Correct answer, C. Explanation. Push-pull works well for bulk liquid removal but is inefficient at low pressure. Once liquid is gone, switch to standard vapor recovery per EPA section 608 and RE guideline K. Pressurizing with nitrogen is illegal. Tank port switching won't help vapor phase. Parallel machines require matching flow specs. Question 21. While examining a newly installed air conditioning system, technician Collell is performing the commissioning process for a 4-ton split system. He verifies refrigerant charge, airflow, voltage, and temperature splits. However, he notices a significant mismatch between the calculated and measured CFM per ton. Despite correct charge and duct sizing, the measured airflow is 270 CFM ton. What is the most appropriate corrective action? A. Replace the air filter at a higher MERV rating. B. Increase blow at motor tap setting or ACM speed profile. C. Reconfigure the condenser fan motor to reduce back pressure. D. Insulate the supply plenum to prevent thermal gain. Answer. Correct answer, B. Explanation. Low airflow, 270 cm ton versus target 400 cm ton suggests underperformance at the blower. Adjusting motor taps or ACM profile increases airflow, aligning with RE 210-140 startup standards. Option A. Worsen static pressure. C. Affects condenser, not airflow. D. Affects heat gain, not volume delivery. Question 22. From multiple perspectives, technician Natalie is retrofitting a condenser unit at a multifamily building. She plans to relocate the unit closer to an egress window for ease of access. However, local code restricts placement near any operable windows or vents. Which is the most important reason for this restriction? A. It prevents physical access obstruction. B. It reduces equipment noise in living spaces. C. It limits the introduction of combustion gases into occupied areas. D. It allows proper airflow clearance for the evaporator. Answer. Correct answer, C. Explanation. EOS-AM and local mechanical codes restrict AC unit placement near windows fans to prevent hazardous gas or refrigerant entry into the structure during malfunction or leak. Combustion gases or refrigerants can pose severe health risks. Noise or airflow are concerns but not primary code violations. Question 23. Considering the evidence, technician Jin is evaluating a split system with poor cooling performance. Pressures are normal, airflow is sufficient, but suction line temperature is much lower than expected and the evaporator coil is frosting. The customer states the issue began after a filter replacement. What should be Jin's next step? A. Replace the thermostat with more sensitive model. B. Inspect the airflow direction and duct orientation. C. Confirm that the newly installed filter is not overly restrictive. D. Lower the blower speed to increase dehumidification. Answer. Correct answer, C. Explanation. A high MERV or improperly sized filter can drastically reduce airflow, leading to frost due to insufficient heat absorption at the evaporator. Although charge and pressures appear normal, low airflow mimics undercharge symptoms. A CAS Standard 4 recommends airflow verification after filter changes. Thermostat and duct orientation are irrelevant here. Question 24. The traditional approach to electrical diagnostics led technician Farad to troubleshoot a blower that fails to energize. The system uses a SEO and capacitor. Voltage at the motor terminals reads 200 fortive and the capacitor is within tolerance. However, the motor still doesn't run and hums loudly. What is the most probable fault? A. Open run winding in the motor. B. Undersized capacitor causing starting delay. C. Faulty relay failing to energize the control side. D. Breaker failure on the line side. Answer. Correct answer, A. Explanation. The SEU humming with full voltage suggests the run winding is open, so the start winding and capacitor cannot rotate the rotor. Per NEC 430 and NATE service practices, this results in motor lockup despite good voltage. Undersized capacitors wouldn't stop operation completely. A relay and breaker are working as voltage is present. Question 25. When considering system balance, technician Shannon observes that the evaporator coil's suction temperature is abnormally high, with low superheat and low subcooling. The TSV bulb is securely attached and insulated. What component may be underperforming or defective? A. Compressor failing to pump correctly. B. TXV stuck in open position or oversized. C. Return duct leak pulling in hot attic air. D. Dirty indoor blower wheel. Answer. Correct answer, B. Explanation. Low superheat plus high suction temperature equals excessive refrigerant flow. A stuck open or oversized TXV overfeeds the coil, which doesn't properly evaporate refrigerant. This causes improper heat absorption. Compressor failure would show low suction high head. Duct leaks and dirty blowers affect airflow but not superheat directly. Assess diagnostics and TXV specs. Question 26. The most significant aspect of energy audits in residential AC systems is understanding the interaction between building envelope and equipment performance. Technician Raj inspects a home with high energy bills despite a new CS16 system. Blower and refrigerant levels are ideal. What building-related factor most likely contributes? A. Unbalanced refrigerant charge. B. Inaccurate thermostat placement. C. Leaky building envelope or insufficient insulation. D. Dirty condenser coil. Answer. Correct answer, C. Explanation. Even efficient systems struggle in poorly insulated or unsealed buildings, causing constant cycling and heat infiltration. ASHRAE Standard 90.1. HVAC alone can't compensate for envelope defects. Charge and coil are irrelevant since system is new and checks out. Thermostat misplacement causes minor variance. Question 27. Across different scenarios, technician Darla performs routine maintenance on rooftop units. During compressor inspection, she begins to remove a terminal cover without using proper PPE. The unit is still energized. What primary safety violation has she committed? A. Not verifying refrigerant type before opening service ports. B. Bypassing the high-pressure switch without permission. C. Opening energized electrical components without lockout-tagout. D. Wearing steel toe boots on a wet roof. Answer. Correct answer, C. Explanation. OSHA 1910.333 mandates lockout-tagout (LOTO) when accessing live electrical components. Removing covers on live circuits risks arc flash, shock, or burns. This is a serious safety violation. Steel toe boots are required PPE. High-pressure switch bypass and refrigerant checks are not relevant in this scenario. Question 20. Examining the consequences of a failed ECM blower, technician Noah determines the module receives 24 control signal and 120 line power. However, the motor does not respond and diagnostic LEDs are blank. What should be Noah's next step? A. Test communication signal between thermostat and ECM. B. Replace the capacitor serving the blower motor. C. Bypass the module and wire directly to motor windings. D. Replace the ECM module or motor as unit. Answer. Correct answer, D. Explanation. blank lengths and proper power suggest internal ECM failure. ECM motors often require complete replacement as the control module and motor are integrated. See OEM diagnostic trees and ECM standards. There is no capacitor in ECMs. Direct wiring is unsafe. Signal issues wouldn't explain blank indicators. Question 29. To illustrate this point, technician Clara installs a suction line on a new mini-split system. She routes the line with 3 9-tided bends over 25 feet and uses long vertical riser before entering the evaporator. Which is the most important concern regarding this configuration? A. Reduced condenser airflow from heat buildup. B. Suction line pressure drop leading to oil return issues. C. Overcooling of the evaporator coil. D. Loss of refrigerant at the metering device. Answer. Correct answer. B. Explanation. Too many bends and long risers in the suction line create pressure drops impeding oil return to the compressor, which can cause failure over time. The CAM Manual S and manufacturer piping guidelines limit fittings and emphasize oil trap placement. Condenser airflow is unrelated. Coil temp and metering loss don't apply here. Question 30. By comparing the performance of a standard split system in a dry versus humid environment, technician Alois notices that cooling systems in dry climates often exhibit higher sensible cooling ratios. Why is this thermodynamically expected? A. Dry air has lower specific heat and absorbs less moisture. B. Humid environments raise the enthalpy of incoming air, favoring latent load. C. Sensible load remains constant regardless of humidity levels. D. Compressors in dry regions operate at lower suction pressure. Answer. Correct answer. B. Explanation. In humid climates, air contains more moisture, so systems must remove latent heat. Dehumidification, reducing the sensible load ratio. In dry air, systems remove mostly sensible heat, increasing SHR. Per ASHRAE psychrometric principles and a CAM Manual J, enthalpy and humidity directly affect this. Options A, C, and D misunderstand psychrometrics.